Okay, so let's do our oxidation reaction first. What was it that was being oxidized?
Sulfide.
Sulfide. So S2 minus becomes S solid. What do we have to do to balance that? Yes?
Add 2 electrons to the right.
Add 2 electrons to the right.
To the right.
That's about the easiest half reaction you're ever going to have to write. Now, what about the other one? Permanganate reduced to manganese sulfate. What do we have to do here?
So can you put like a hydroxide then on the right?
Where would you get hydroxide from?
It's a base.
Okay, but we said we were going to treat it as an acid until the very end.
So you so I do water.
So again, we're going to have to balance that oxygen with water, but we're not to that point yet.
Sulfide.
We still got to take care of that sulfur. We're going to have to add sulfide to this. Okay? So now manganese is balanced, sulfur is balanced. What about oxygen? On this side, we're going to have to put 4 waters, 4 H2O. Now oxygen is balanced, but we've thrown hydrogen in. So we need 8H plus over there. All right. And now what about charge? We have no charge on the right. Total charge on this side is plus 5. Okay? So there's -1, -2, -3. -3 compared to plus 8 is plus 5. That means what are we going to have to do with electrons? We need 5 of them on this side. Let's see if it'll let me do this. There we go. Okay, Alicia?
So why do you have to why do you add H plus instead of OH minus?
Because we're treating it like an acidic solution until the very end. Because this way I don't have to teach you a second way to go through and do this.
Okay.
You can do it the same way and just add 1 step on the end to fix it.
Okay, really?
Yes, and it'll work, I'll promise.
No exceptions.
No exceptions. All right, what do we have to do to balance these? Now multiply the top by 5. So this is 5 sulfide, 5 sulfur, and 10 electrons. What do we do down here? 2. So this becomes 10 electrons, 16 hydrogen, 2 permanganate, 2 sulfur, 2 sulfide, excuse me, 2 manganese sulfide, and 8 water. Okay? Now let's see if we can cancel anything. I think the only thing we can cancel here is the electrons, isn't it? Oh, wait a minute. Can we cancel sulfide? I don't think so. Aren't the sulfides all on the left side of the arrow? They are, aren't they? All right, so let's just start bringing them down. 16H plus, that's accounted for. 5, 6, 7 sulfide. So 5, 6, 7, that's accounted for. Plus 2 permanganate. That's everything on the left, isn't it? Okay. And so now we can do that. So on this side we have 5 sulfur. That's accounted for. And 2 manganese sulfide. So that's accounted for. And 8 water. I'll leave myself enough room there. Plus, okay, 8 H2O. Okay? Are we okay with this? All right. Now let's double check and make sure everything's balanced. Yes, sir.
Do you, when you add them together, do the ions go before compounds, or does it not matter what way you?
It doesn't matter. I just, in this case, I put in that order because that's kind of the order they came in. And hydrogen was the farthest to the left, and then sulfur, and yeah. But it doesn't matter. You're ultimately going to have to account for them regardless of where you put them. All right, so 16 hydrogen on that side, 16 hydrogen on this side, that's good. 7 sulfur, 5, 6, 7 sulfur, 2 manganese, 8 oxygen, 8 oxygen. Looks good. Let's check the charge. There's no charge on this side. We have a plus 16 on that side, minus 14, 15, 16, minus 16. It's all balanced. Now we have to deal with that one small detail. The fact that this is not happening in acidic solution, this is in basic solution. Okay? So here's the trick. You're going to love this. Okay?
Go back to
Can H plus exist in a basic solution? Not in any appreciable amount. What would exist instead? H minus. What we're going to do is this. Our assumption when we did this with acidic solutions was that there was as much H plus as we wanted. Well, in a basic solution, we're going to make the same assumption. We're going to assume there's as much OH out there as we want. Well, how much do we want? Well, in this case, we want enough to neutralize that H plus. So how many OHs do we need? 16. So here's what we'll do. We'll take this, we'll add 16 OHs and make that 16 H2O. Okay? Now, just like in algebra, if we add 16 hydroxides to this side, we're going to have to add 16 hydroxides to this side. Okay? Now, by doing this, we've essentially removed that and replaced it with water. Okay? Those two are both gone. Now we have water over there. Yes?
Doesn't that mean the hydrogen was there though? Like, if you add the OH to hydrogen, so where'd that hydrogen come from?
Well, in reality, it didn't. Remember, this is a model. This doesn't represent the physical reality of what's happening.
Yeah, but wouldn't you need that hydrogen to make H2O with the, you put 16 OH?
Mm-hmm. If this were really what's happening, yes, that's what we would need. But this is not intended to represent step by step what atoms are reacting. This is a bookkeeping system. This is just a model. The model doesn't always match the reality exactly. So I'll give you advice now that I've given you in previous times: don't eat the menu. Well, a menu represents food, but it is not food itself. Okay? All right.